In this lesson, some of the appropriate technologies for food preparation are described, together with a discussion regarding the pros and cons of each of them, and compared with the traditional and inefficient three-stone fire. Technologies for cooking are the first category. The technical aspects of many common models of stoves for boiled water and cooking food are described, as well as their benefits and opportunities. Additional clean cooking technologies are the second typology presented. They are cooking devices supplementary to the classical cooking stoves, which allow to cook and eat food without the use of any fuels. Thirdly, three stoves components are explained as useful cookers add-ons, which increase the efficiency of the stoves. In conclusion, the final part of the lesson is devoted to the biomass-based fuels alternative to firewood. Stoves are here described starting from the least efficient and most polluting devices up to the most efficient and less polluting. The first are traditional stoves. The stoves made of mud are the least efficient and most perishable. These are devices very easy to build, but with very low performances. Metal stoves are quite more efficient, and they can be easily constructed by using locally waste materials and by cutting out the stove components from a prefabricated stencil. Due to these reasons, the cost is very low or zero, but they have a very short lifespan. Among the traditional devices, clay stoves are the most efficient. They are made of mud fired in appropriate kilns, which increase their durability and reliability, but require specific construction skills and molds. The second class of stoves includes the so-called improved cook stoves, also known as ICS. Rocket stoves are the most efficient ICS fueled by firewood. The name refers to a particular design of stoves, which are characterized by the presence of a combustion chamber made of two orthogonal parts. Different models exist, and they could be built with local waste materials such as cans, using sands or other materials for the insulation. Microgasifiers are improved cook stoves, which realize a two-stage combustion, pyrolysis and gas combustion, that allow to reach a more clean and efficient operation of the stove. In order to reach a higher level of efficiency and cleanness, it is necessary to consider stoves lighted by different fuels. They are named modern energy stoves. Among these, ethanol, kerosene and LPG stoves are worth to be mentioned, together with electric stoves such as microwaves and electric plates. Now, let's come to introduce the supplementary cooking options that work as additional. Solar cookers are technologies that aim to cook by concentrating solar energy on the pot containing food. Homemade box cookers are the less efficient solar cookers because they weakly concentrate the rays on the pot, but they work satisfactorily as food warmers. They can be easily homemade with a corrugated paper, reflective foil, and a transparent plastic sheet. Panel cookers are the most common type of solar cookers thanks to their easy and low cost of construction by using corrugated papers, reflective foils, and a transparent bag. They concentrate better the sun rays, but they are very perishable with a lifetime of few months. Parabolic cookers are the most efficient solar cookers, but they are very expensive and not easy to build. They consist of a parabolic reflector in which the pot is located at the focus point thanks to a stand system to support it. A A-basket or fireless cooker is another supplementary cooking option. It is a simple insulated container where a partly cooked food could be stored in order to continue the cooking without the need to consume further fuel and external heat. A pot containing food could be firstly brought to the boil by using a traditional stove and then placed into a hay basket in order to complete the cooking without consuming further fuel. Food continues to cook over a longer period of time inside the fireless cooker, using its own stored thermal energy and reduces the fuel use. Let's come to introduce some technical expedients which could increase the performance of solid fuel cookstoves. The main element which increases the thermal efficiency of a stove is the insulation material, while an increase in the air draft helps in decreasing the emissions. These two components depend on the design of the stove. On the contrary, the pot skirt is a very simple but little known additional component that can be added to each type of stove. It increases the efficiency by enclosing the pot and forcing the thermal exchange between the pot and the hot gases. In conclusion, alternative biomass fuels other than firewood are described. Peat results from the accumulation of organic matter created by an incomplete decomposition of wetland vegetation. It contains from 10 to 25% more specific energy content than wood, but its combustion could be more smoky. Briquettes are more efficient fuels made by compacting different biomass wastes into a mold. Charcoal is the direct product of the pyrolysis of wood, that is the combustion of wood in an environment with reduced presence of oxygen. It has a high energy content, almost double than firewood, and it burns producing less smoke. But the process to produce it is characterized by a low conversion efficiency. As a consequence, the impact on deforestation could be higher respect to the use of firewood. Lastly, biogas is the result of the partial conversion of animal, human and agricultural organic wastes. The biogas reactor, called digester, produces methane and other combustible gases, which can be used for cooking with a higher efficiency compared to charcoal and firewood.